This last example, this is going to be the most difficult thing you're going to run into in this section. And so the reason why is there's something called factoring by grouping. And it might be something that you'll need to look up. So factoring by grouping, and the reason why we have to do this different method is if you look before, we had a value, we had an x right here that we could just factor out and everything worked out nicely. But here we don't have an x so that we can factor out. So we're stuck doing this grouping method, and it's really not too bad. What we're going to do is we're going to look at two different groups. So let's go ahead and set this up. So here's one group. We have this left group and we have this right group. So what can we factor from each of these? And so I'm looking at this one. What can I factor? What do these both have in common? The most I can take, 2 and 3 don't have anything in common, but x squared, I can take an x squared from both of those. So I have x squared times 2x plus 3. So that's for that group that I highlighted in yellow there. And let's look at that negative 18x minus 27. So what can I take from both of those? I'm looking at those. They have a 9 in common, so I can take out a negative 9. We'll go with negative 9 because they're both negative. So I'll factor out a negative 9 from those. So put negative 9, and then this will become 2x, and then negative 27 divided by negative 9 is positive 3. And the whole goal of this is we want to figure out with grouping, we want them to be the same. Notice right here, 2x plus 3, 2x plus 3, those are both the same. So we want those to be the same. Otherwise, something went wrong, and you got to go back to the drawing board. So the good news is since both of those are the same, we're going to kind of do this thing. We're going to take both of those, and we're going to factor them out. You know, like picture this. If this was instead to be a. So instead of 2x plus 3, it's a. Well, both of these would have an a in common. I would factor them out to the front and be left with x squared minus 9. Now, instead of those being a, though, let me put a little more space here. Instead of those being a, they're not a, they're 2x plus 3. So I could factor out that 2x plus 3 to the front, just like I did with this a. And that's what you would get. So that would actually be your answer right there. Let me move that out of the way. Actually, I'm going to delete it. And here we are. And so it's not quite done because we still need to figure out what are the zeros. So I'm going to set p of x equal to 0. And we're going to solve each of those. And we're actually, hang on before I continue, x squared minus 9. I just realized we could factor this even further. X squared minus 9, doesn't that factor down to, in our previous example, we already did that one, that's x plus 3x minus 3. And now I'll go ahead and take that p of x and set it equal to 0. And so we'll get 3x values. So we'll have x equals negative 3, 3. And the last one's not so obvious. So the 2x plus 3, if it's not that obvious, you can always sit there, set it equal to 0, and solve it like an equation. Really using algebra to manipulate it to the situation, to the answer that you need, which is really good if you can do that. So I'm just going to take that. Let me just move this over here. So just a heads up with that 2x plus 3. Let me just kind of underline that so we can see where that came from. And there you are.